This video will walk you through the modeling Galestown activity and give you the example of Storm 1 before you complete Storm 2 independently. In Chapter 1, we've been investigating what caused the rainfall in Galestown. Remember in the introductory video that we watched, they built a new lake in Galestown. Our goal today is to show how the amount of surface water caused different amounts of rain in Galestown using the items in the modeling tool key. We're going to be looking at two different storms here in this table. Storm 1 happened when there was a low amount of local surface water, meaning that lake wasn't built yet. When there was a low amount of surface water, there was a mild amount of rain, about 15 centimeters, or 6 inches. In comparison, Storm 2 occurred once the lake had been built. There was a high level of local surface water. This created a moderate amount of rain, about 38 centimeters, or 15 inches. We're going to show how these differences created differences in the amount of rain. To be more specific, we're going to explain how the differences in local surface water created differences in the amount of rain. We have a handy checklist right up here to help us, and so I'll be navigating you step by step. Our first step is to label our model Storm 1 or Storm 2. So let's turn to the model now. We'll start by thinking about Storm 1, when we had a low amount of surface water. On our checklist, our second step, I'm scrolling back and forth, is to show the temperature of and water vapor inside of the air parcel. I know that in the before image, I have a low amount of water vapor. The reason is that I only had a small amount of surface water on the grounds to evaporate into water vapor. Remember, evaporation is the process of liquid water becoming water vapor. So my water vapor is low because I only had a small amount of water on the surface to actually be evaporated. I know that before rain happens, the temperature in my air parcel is higher than the temperature outside because that cooling process is what's going to cause the condensation. Remember, condensation is cooling. You should recall this from our model that we drew in class yesterday that you have a few pages before this one in your binder. Condensation, which is cooling. So, as our air parcel cools down, we know that condensation will occur. And our water vapor will become liquid water. Again, the reason that's happening is because energy is leaving our air parcel as it cools down. The temperature outside of our air parcel is lower, so the temperature inside of the air parcel will also decrease because it's releasing energy into the broader air, or the outside air. The liquid water in our after image will be low. There will be more liquid water than in our before image, but we only started with a low amount of water vapor because we only started with a low amount of water on the ground. Because there was low water on the ground, there was low water vapor, and only a little bit of water vapor to turn into liquid water. The temperature in the after image is also low because now the water parcel has cooled. The temperature outside hasn't changed. It's still low. The other two parts of our drawing we haven't yet completed are to draw a small cloud indicating that we have a little bit of liquid water in the sky. We also want to clarify that our surface temperature, by temperature I should have said water, our surface water is still low in the after image because we have a small lake. Rain will be falling from the sky, but only little tiny droplets. Notice that because there was only a small amount of surface water, there was only a small amount of water vapor, which meant that after condensation and energy transfer, that's this arrow here, outside of the air parcel happened, there was only a low amount of liquid water in the sky, which caused a small amount of rain. That's what occurred during Storm 1. Now, I think we've accomplished everything on our checklist. We've shown our temperature of the water vapor, the surrounding air, we have the energy transfer arrow, we showed the amount of liquid water inside the air parcel, we outlined our cloud and rain, we outlined our surface water, and we did some annotations about evaporation and condensation. You can go ahead and check off Storm 1 if you've been following along and taking notes. Your job independently for the rest of class is to work on Storm 2. Your model will be similar, but there are some major changes because now you have a high amount of local surface water and a moderate amount of rain. Your job is to show why that happened. Why did the higher amount of surface water create a moderate amount of rain? Demonstrate the water cycle in the same way we just did in part 1. When you're finished, raise your hand so that Ms. Kinez can check your work.